Today we are going to discuss about the topic parametric and non-parametric methods. So here we are going to conduct a group discussion. Common situation is a researcher wants to analyze examination work of students. Sometimes the data follow assumptions such as normality, while sometimes the data may be skewed, contains outliers or be in a ranked form. The researchers therefore needs to decide whether to use parametric or non-parametric statistical method. The discussion question is, which is more appropriate for statistical analysis, parametric methods or non-parametric methods? You can start your discussion now.
Our topic for discussion is the parametric and non-parametric methods. Both are important statistical approach used for the analytic data and marketing research. Parametric methods generally mean that assumes and about the population distribution and involve the parameters such as means and variance. Non-parametric methods make fewer distribution assumes and are useful when they assume of parametric methods are not appropriate. The main point for our discussion is not to decide that one method is always better, but to understand when each method should be used.
I would like to explain parametric methods. Parametric methods are statistical techniques that usually assume a particular distribution of the population, often approximately normal for many common procedures. They make use of parameters such as the mean and standard deviation. Examples include the test ANOVA, Pearson correlation, and linear regression. When the assumptions are reasonably satisfied, parametric methods can be powerful and efficient because they use numerical information in the data.
What are non-parametric methods? If an assumption required for a particular parameter method are not appropriate, we can consider non-parameter method. These methods generally make fewer assumptions about the underlying distribution. Many non-parameter tests work with ranks rather than relying directly on original numerical values. Examples include the Matt-Whitney U-test, Bellicortion signed rank test, Crucial Willis test, and Superman rank correlation. They are particularly useful for skewed data, original data, small sample, or situation where outliers make a parametric analysis less appropriate.
Before using a parametric method, we need to check whether its assumptions are reasonably satisfied. Depending on the test, these may include approximate normality, independence of observation, and assumption about variance. Outliers are also important because they can strongly affect the mean and standard deviations. For example, if we are comparing examination mark and no students score between 40 and 60, but one student scores 100, then extreme observation may influence the result. Therefore, we should examine the data before selecting the statistical test.
So the role of outliers and data distribution. So I don't think the presence of one unusual observation is automatically means that we should reject the parametric methods. First, we need to investigate the observation, and it could be genuine value or it could be data and clear error. So we should first examine overall distribution of the data and determine whether the observation has an extensive influence on the analysis. So if the data are substantially skewed or outlierly seriously affects the assumption, a non-parametric method may be more appropriate. So the decision should be based on the characteristic of the data rather than simply the existence of an unusual value.
The comparison of both methods. Both approaches have advantages and limitations. Parametric methods generally have stronger assumptions, but
identify the type of data and examine its distribution. We should check for outliers and consider whether the observation are independent. We also need to consider the sample size and the assumptions of the specific statistical test. For example, when comparing two independent groups and independent sample, the test may be appropriate if its assumptions are reasonably satisfied. If those assumptions are sustainably violate a man destiny, new test may be considered.
No, I don't think we can say that one method is always better than the other. The appropriate method depends on the data and the research question. Parametric methods are generally preferred when their assumptions are reasonably satisfied because they can be powerful and make effective use of numerical inputs. Non-parametric methods are useful when those assumptions are not appropriate, particularly with original data. Substantially, skewness or problematic outliers. Therefore, the correct approach is to understand the data first and then select the appropriate statistical method.
Can anyone conclude the solution?
So parametric, non-parametric methods both are valuable statistical approaches. Parametric methods are suitable when their assumptions are reasonably satisfied, while non-parametric methods are useful when those assumptions are not appropriate. So therefore, the choice should be based on the research question, type of data, distribution, of layers, sample size,